Hello, good afternoon. Hopefully, you are able to hear me because I have been doing some other series. And when I do something like this, by closing my face to the monitor, seems like you're having trouble to hear me. I will try to talk only when I am, like facing the camera. So you can hear very well. Hopefully, there won't be any problem with the audio. So my name is Caleb Ruiz. I'm a software developer, and I've decided to embark in this series of videos, another series of videos. This one related to programming, and I decided to use Elixir, a programming language, because I think it's a very practical programming language with lots of features from a few uh, programming paradigms like functional programming or even protocol oriented programming a little bit. And yeah, I will be coming up to this screen to see the time and put me on track because I tend to talk a lot. I don't know why. And I decided to put this in a live version because I don't have time to record the video and then edit the video with lots of features. It will be more like polished if you take the time to record the video first and then and produce it with or enhance the video with lots of images and transitions and correcting the audio, more like professional video production is achieved by recording first. But I honestly I don't want to spend time in that. I want just to deliver the information because I think that's the important part, and hopefully you will get something from these videos. And it's not required for you to know how to program. It is targeted to people with zero programming skills. You have been hearing that it is the end of programming, but it isn't. Perhaps it will be transformed, but we will never stop interacting with computers. You communicate with computers by giving instructions. And yeah, let's get started by defining what what is it. What's a computer? Why do you want to program a computer? And prior to this live session, I opened lots of web browser tabs. At least I will have these images ready for you. That's the least I can do if I don't want to record any video. I tried like 3 months ago. I recorded a video, but then it was like a lot of post production. And I am a software developer. But I want to share at the same time this information. So yeah, let's get started after 5 minutes. Since this is the first video, we get to talk this much. In the next videos, we won't be saying the same because we already did it in this part. So we will save time. In the video description, there will be resources, links to my website, so you can download any extra resource that's needed. So yeah, what's a computer? And according to this etym, etym online uh, dictionary is one. I don't know if you can hear me. One who calculates, a reckoner, one whose occupation is to make arithmetical calculations, you know, from compute, and calculating machine of any type. And then they go into the electronic computers from the last century. You know, it feels like on all time, but it was like almost 100 years ago. Okay, what else? Compute, which is over here too. I didn't know from compute. But remember, one who calculates, one whose occupation is to make arithmetical calculations. Compute determined by calculations. So yeah, I am reading this, and there's a lot of examples. So a computer is a device, these days an electronic device that makes two things, performs calculations, like it says over here, and remember results by having access to a memory, like you when you remember your age or your address. Okay, why did we invented computers, electronic computers? This happened been the case since we were humans in our civilizations. Why did we have these necessities to calculate? And according to Mathematics for the Million by Lancelot, it says that it was the need for survival. You People started counting their animals in their flocks, you know, and with the advent of money, more sophisticated forms of calculations were uh, born. And so the story goes, and we were coming to our present days, and at some point, and there's windy weather over here, which is cool. Uh, Here's another definition. A computer is a machine that can be programmed to automatically carry out sequences of arithmetic, again, or logical operations. So yeah, basically it's the same that a team online. However, you find this picture, a human computer. Look at this, female computer, and it has a microscope at this device. So this lady is called a computer. Why? Because her job was to perform calculations. Look, he's having a pen on her hand. And there is the reason for that, which is not cool. Mm, the fact that, look at this woman were often hired as computers because they could be paid less than their male counterparts, which is a disgrace. Hopefully, things are getting better these days for women. They deserve the same rights. We are all the same. So yeah, they were helping in performing calculations by hand. Now, as humans, we started to innovate. Let's see the time. We'll innovate. So yeah, and this this is the abacus. I saw this when I was in elementary school. Not this version, but the toy version that children have back in the day. And I didn't know how to use it. But it is a device to help you to perform some counting. And it is being shown here, so you can see that we were always coming up with ideas on how to assist us in these tasks. Here is the Charles Babbage. You know, hopefully, perhaps you have heard of this guy. It's all about calculator. But again, this is an ancient times because uh, it's like 400 years ago. So we are scrolling in this Wikipedia page to see the pictures. It's a journey in the time. Here we have the Colossus, which is a computer. And look again, we have women over here working with these computers that were gigantic. You couldn't afford to have one in your home. Okay, and we arrived to the modern era of computers. I'm seeing a lot of times this name over and over, Turing, Alan Turing, and you maybe saw this picture of this guy. This guy appears over and over in this article because they developed the mathematical foundations. He, among other people, of electronic computers that you know these days. You know, this is microelectronic, and we will come back to this because we are now in the era of mobile computers, microcomputers, and we have the Apple II. I didn't see this because I am from the mid 80s. I was born in the mid 80s, so this is from perhaps for the people that were born in the 50s. So perhaps you didn't see this either. Well, these guys embarked in the mission of make this like an appliance for all the families to have one, like a television, perhaps. But why again? Because we were in need to calculate. Okay. And with that in mind, don't worry. This training is not focused on mathematics, and you shouldn't be afraid of mathematics, by the way. We will show only very few things related to that area, but I invite you to not be afraid of mathematics and start thinking and revisiting some topics if you have time. So yeah, remember, you don't. I'm not expecting for you to know lots of mathematics. I don't even know a lot of mathematics and zero programming skills, but it is likely that you know how to count. Look at this. You know, one, two, three, four, five. We started again, as the book says, to count. And then we come up with these figures, these little drawings that we call numbers, that represents the concept of having five objects. And we were always adding more sophistication, more sophisticated tools and notations. And we arrive to more drawings, you know. This is a four, number four, and this is a number nine. You know, this is an addition. 5 plus 4 equals 9. You know that. And more, you say, okay, I now I want a shortcut for addition. And you come with this. This, uh, if you don't happen to know what these symbols means, worry. This is times multiplication symbol, which in computers is written like this, but perhaps you have seen it as an X, as a point, or even with parentheses, or if you know some algebra, even without nothing in between. Okay? What in arithmetic is whether it's this, or if you know some notation on computers, it is this asterisk. Okay? Now, you need to know what happens when you have. Okay, oh, okay, the marker. You already saw two symbols. The plus sign, this is a 9, 9, 8 times 3. You need to know, and in here will be very obvious why invented tools. This is like rather short expression, but you might be wondering, why should I do first? It is this addition or this multiplication, and we arrive to something called the precedence of operators. Which operators? The arithmetic operators that you happen to know. Look at this. This is a parenthesis. Some brackets. Don't worry about this. I'm going to say what it is in a moment. This is a slash for division. So this little table will tell us the order in which operators should be carried out. This has, we say that we have that this parenthesis has higher precedence. This is to denote powers, exponentiation. If you saw something like this, it's a number two, and a little three over here. Perhaps you know that this is nothing but a shortcut for multiplication. The same number three times. This number three times, which is 8. And this happened to go first. You know, we are from more important to less important, quote unquote less important, because these are like fundamentals, so they are very important, but you know, these have, they say precedence. It goes first. Coming back to this expression, an arithmetic expression, we consult this table because in here we don't know what to do first. Should I do the plus, the addition, or should I do the multiplication? So we come here to this table and see that the multiplication goes first because it is above uh, this plus sign, and we draw this little thing 97. And perhaps you are very good at mathematics, at calculations, and you did this by memory. But electronic computers aren't that smart after all, so they carry their operations in order. They aren't smart like you. So the computers, electronic computers, need to be very specific on what goes first, what should be doing at the end. And in code, in the system, is this precedence. So if you enter this expression in in a computer, in a program, accepting these expressions, you will receive the answer. But the computer is doing kind of these steps. So in here, I'm trying to move you, if you aren't there already, to this sort of thinking and what happens first, what happened next, what happens next, what happened next. 9 times 3, 27. Now it's very obvious that you need to just rewrite again this. And now you can perform the addition. And now it was very easy, right? At first you were like confused, um, asking yourself, oh, I don't know what to do. But with the specification of the precedence for operators, and you were able to move on, move along, and you have your answer. I'm going to delete this. I'm not rushing, I'm taking my time. If you are bored already, I'm sorry. But hopefully you are enjoying this as I am. Now that was a very short arithmetic expression, but now let's suppose you have this. 5 plus 10. This is a 0. Divided, which is this, by 2 times 3 plus 5 minus 1. I think I went crazy with this one. Now you have this expression, and again, you should just look at here at this table and start working. But this is the last one that we are going to do. Now I want you to imagine if you have a gigantic arithmetic expression. It will be tiresome for you to carry out all the steps needed. But people were doing this kind of work back in the day manually. So it was a need to invent computers to get help, you know? So in here you will say, okay, so parentheses goes first. They are at the top. So you just draw this little thing to help you visualizing the stuff. It's not necessary, but it feels cool. And you rewrite the entire thing. Note all the thing. And you can proceed. So how do you proceed? You have one division and one multiplication, and they have the same precedence. So you ask yourself, now what I do first? And when you encounter the same precedence, you start working with the operator. These are called operators. These are grouping symbols. You start with the operator that is more to the left. And in this expression, you have multiplication, you have division, but the one to the left is division. So you perform the division first, which is 5. Okay, now it's very easy to continue because there is only one. Plus 4. This is a 4. And you might be tempted to do it at the same time and to say, okay, it's 24. But even when you are saying that you did it at the same time, most likely your brain did it in 2 steps. I'm guessing that's the way the brain works. Even when you are very fast and do this by memory, I think you retrieve it from memory if you happen to know this by memory, or do it very quickly and then go over here. But yeah, if you are going to learn to think mechanically, procedurally, you come here again to the table and see that plus is meant to be performed, but you have two. So the one to the left, which is here, and in here you can say, I know from mathematics that it doesn't matter, and you can perform these two and it will be the same result. And you know that, but the computer doesn't. 20, and we arrive. The solution, you need, I would like for you to get some practice with this. So I decided uh, to prepare in advance 5 exercises. That is not a lot, but the energy, good thing Windows notify us. Great. uh, Most likely you, oh yeah, uh, I prepared this early, and like these are only 5 exercises because you want to spend you can spend entire days doing this as pastime, but just get acquainted with this thinking of what happens first, what happens next, doing things mechanically, consulting some information like the higher precedence operators in the table. You are consulting, going somewhere to retrieve information and applying what you saw. That's the spirit of this